starting to record. Sorry, I should have said that first. So for the celebration, a couple things. So one, it is Thursday, so in 2 days. Hopefully you guys will be right elbow deep or whatever. I will open my office hour. I open the Zoom at 4:30 until 6, and the celebration will magically show up in, I don't even know what week we're in, week 4 folder. At 6 o'clock, it will appear. You print it or open it. If you don't have a printer, just write out your answers in the same order. If you have a printer, that's wonderful. So it's going to magically appear at 6 o'clock, and then you just have to submit it by 8 o'clock. You do not have to come to Zoom at 6. You can. I will be on here from 6 till 8. So if you have questions, you just come on. I only let one person in at a time. So just be patiently waiting in the waiting room. And so kind of realize that, just have your questions organized, because you don't get me for, and don't wait until the end to come and ask your questions. So I do ask that when you submit it, after you submit it, that you check in and have me say, yes, I can see it. I've only had one issue, and that's Tristan, and I think we figured it out. So Tristan, I think it's also your camera, because I had that issue last term, but just make sure the issue Blackboard had last term seems to not be happening this term, where some people, actually there were a couple of you, just make sure it uploads. And a reminder, there is a bonus email. We already did the answer to it. So you just have to respond and tell me what the answer is, and you get a bonus point. And if every single one of you does it before Thursday, you all will get 2 bonus points, 2 points added to your celebration. And then the other reminder is that's just your responsibility to look into the grade book and see if you have any missing assignments, and make sure you get them in and submit them. All right. A couple other things I need to go through here is there is a lab this week. So normally on Thursday, we would have the celebration and then we would go to lab. The EF means empirical formula. So that's the video that had been up there on the YouTube. It's at the bottom of the list right now. It's like a 9-minute video of me in lab. And so I posted the lab, I think, yesterday. And so you just have to fill in the data and do the empirical formula. I walk you through kind of the steps of how to do it, and then you just analyze. So it is like 4 pages because your labs are 15 points. And I did make it due Sunday because I do know you guys are studying for your test. And I will have an office hour Saturday morning if you have questions on that. Next Tuesday, you do have a study set and worksheet due, because normally today we would have study set, we would have, this should be a 3-hour class on Tuesdays. And so the hour that we're not having today is recorded. So for you from 151, the good news is it's oxidation reduction. So the study set, oxidation reduction is really, it's a lot of this ion positive negative. And so it will be review. I thought about it, what to put on the, after the celebration, and yeah. All right, so that is a pre-recorded lecture that will appear on either Thursday night or Friday or Saturday, and then I'll start putting the stuff in the next folder. I haven't put it up there because you want to focus, but there will be notes, and it's like a 50-minute video that you watch, and you can fill out your notes, and then we have a study set and worksheet. So, and then we keep going. All right, so this good. This table, you guys remember that? That's on there. That's how the celebration starts. So S is sulfur, even no matter what you wanted to call it, Max, and several others of you had wonderful names. Atomic number. So periodic table, right? 16, right? That number is our atomic number. And here we go. So again, if you're on the board, you have to count to argon before you can answer this. Where else do I put the 16s? What's that atomic number mean?
Protons.
Yes. Who was that?
Maddie.
That's what I thought. Where else does it go, Maddie?
It can go in the electrons.
Does it on this one? I think it does, doesn't it?
Yeah, on this one it does.
On this one it does. Great answer. The other two it does not. So I wanted to mention that when we learned about this was in the first week, I think the first class, before we learned about ions. On the periodic table, pretty much everything's ions. Here we go, somebody else. Why is pretty much everything ions on the periodic table? Or what is not going to be found as an ion? It's what we just learned. It's the octet rule. So they all want to be like the noble gases. So in that first moment, in the Big Bang, or when a star is born, the elements lose electrons because they're not stable. So sodium is not stable as sodium. It's going to be sodium with a +1. If there's no charge given to you, make your protons and electrons the same. The mass number is that number there. A reminder that these all have to be this chart. Everything is whole numbers. So why are they whole numbers? Because they're particles. So you can't have a part half of a neutron. And that's what our rule is in here. I think this is all going to change. But so to find the neutrons, we subtract. So the protons and the neutrons together will give us the mass number, right? So the mass number is the protons plus the neutrons. And that's because they're the massive subatomic particles. They make up the mass. The electron mass is so small, it's we don't usually consider it. All right, the protons always tell you the element. I really did 16 again, so it's sulfur. And so now it has extra electrons, so it's going to have a -2 or a 2 negative. This time it is 32, so we'd say 32. Now, technically, the name changes. So what is the name now?
Is it sulfide?
It is sulfide because it is now an anion. This was a question I think you'd asked me, Major. Technically, we'd say sulfide ion, but sulfide because it's an ion. I do have another question because these guys are isotopes, technically. And so does anybody remember what that term isotope means? It is a word you should know for chemistry, first chemistry midterm. Goes with question number 2. All isotopes have the same number. So they have the same protons, meaning they're the same element. They were both sulfur, but they have different neutrons or different masses. All right, and then the last one, it is not element 54. So just be careful of that. Now that we've learned ions, when you do your chart, you have to subtract the 136 minus the 80 to get the 56. It is element 56. Did I do this right? Yeah, barium. So the atomic number is 56, and you would need to show the barium with a +2. So you could say barium, or you could say barium ion. No, if you wrote barium with a Roman numeral 2, you'd get it marked wrong. Why would you get it marked wrong if you showed the Roman numeral 2 on that one?
Barium is a metal, or sorry, it's not a transition metal.
It's not a transition metal, right? So barium is in the first two columns. So we don't use Roman numerals with them. Major, did you have a question?
Yeah, do we have to put the charge on when we put the element symbol?
Yes.
Okay.
If it has a charge, if the electrons are different. So the very first one, no charge because it was a neutral atom. But if the electrons are different, you do have to show the charge to get that elusive half point. So, all right.
Okay, so you just subtract the electrons from the protons to get the charge.
Um,
I'm sorry, the other way around.
I don't think of it that way. So if you gain, you become negative. If you lose, you become positive. So maybe what you said is right, but I'd have to think too much. Yeah, I know. Somebody said that. They said my listening skills are getting better. And so they're like, I'm not very good at auditory and I'm terrible. And I'm seeing this as a great challenge for me to grow and learn how to listen better.
Thank you.
So number one, similar mass, neutrons and protons. They don't have the exact same mass, but about the same. A reminder, period 3 halogen. There is no period 1 halogen. So it is chlorine. So don't do 1, 2, 3. It is chlorine, the third period. Yeah, when I used to hand out the periodic tables, Major would remember this. First thing everybody would do was I would hand out the periodic tables before the test because everybody would spend the first 5 minutes making notes on their periodic table. But this would be chlorine. All right, some true false. So we're happy, sad. So nucleons do not need to be the same as the electrons. I threw this word in here to remind you, what does nucleons mean?
Protons plus neutrons, right?
Yeah, so protons and neutrons. It is the particles in the nucleus. So the protons and neutrons, the massive ones, are called the nucleons. So it is your mass number. B is true. We'll go with a happy face there. Yeah, because the nucleons, we say virtually all because the electrons do have an itty bitty wee mass, but the protons and neutrons are the mass. And C, again, is possibly one of the most wrong statements. The density is extremely high. The nucleus is the mass in an itty bitty space. All right, and then some ion questions. Non-metals gain, right? Except they gain and they form anions. So that would be wrong. Or you put a sad face. On E, no, transitions can only form positive. They cannot form negative. So that's wrong. All right, how about F and Y? Yes or no and why? Anybody?
Is it because it's already a noble gas, but the chlorine is still a halogen?
Well, yes. So when it becomes chloride, it gains an electron. So it's like you and me. It's like the Thanksgiving principle. If you eat more food, you're going to get bigger. It gains an electron, but it doesn't gain any protons. So it does actually get larger. All right. And then G, we talked about at the beginning of our study, said G would be correct. So an ionic bond, electrostatic, again, just means positive, negative, attract. So there's considered only 4. Actually, this is not true anymore. A couple of years ago, there were only 4 forces. And so electrostatic was one of the forces. Gravity was another force. And then the other 2, which were the 2 strongest forces, are in the nucleus. They're called the strong nuclear force and the weak nuclear force. And they actually admitted they made them up. They said there has to be a force in there to explain how all that mass can be in there. There are other forces now, but it goes well beyond my understanding. There's a whole bunch of them now. I can't remember what they all are. I've read about them. All right, but we just deal pretty much with electrostatic positive and negative. All right, number 5, you had a question similar to this on your worksheet. So Tristan, this was the one I said you had a question on. I said I would go over it. So what you're going to do for these is you take the AMUs, and the abbreviation for AMU is also a U. So AMU stands for atomic mass unit. We saw that way back, like all of 2 weeks ago. It seems like years ago, decades, right? Times the percent. So you're taking the AMUs times the percent, and then you're adding them. So 70, and then I add it to this one. I just changed my percents to a decimal, so 39.359, and we add them together, and we should get, it must be gallium. Did somebody punch it in? Did we get 69.72?
That's what I got.
All right, and AMUs, or that funky U. So you should get a number on the periodic table, meaning this is average atomic mass. This is that number that's underneath gallium right there, the 69.72. So it's an average. Those are isotopes, and those are their mass number. So the mass number, again, is exact. It's a whole number because we're counting protons and neutrons. This is a measurement. So this has a limited number of this has sig figs. So this is exact because it's counting, and that's a measurement. So gallium is a metal. Jeremy, I think, did his talk on gallium, because gallium's the one that melts in your hands. There's all these cool tricks. The nucleus has protons, so the nucleus has 31 protons, so it would be a plus 31, and that's for the 31 protons. So the nucleus does have a charge because it doesn't have the electrons to balance it, and so it's just the number of protons with a plus. An element with similar properties, so we're looking at a family. So probably indium or aluminum. All right. So it's ion. So gallium, it's under, you could, on this one again, indium or aluminum. And it's going to behave like aluminum. So it's going to be a +3 like aluminum. It can actually be a +1 also, because it is variable, but that goes beyond where we're at right now. Right, and then nucleons, the more abundant, you're going up here and just looking at these. And so it would be the X69, because it was 60%. And that 69 is the nucleons. So on the worksheet, I think I asked for neutrons. So just a word for all of you on the celebration. Make sure to keep breathing. Don't like rush through it. I mean, you do have a limited time. But yeah, sometimes I ask neutrons. Sometimes I ask the nucleons. I don't know. So this one was nucleons, so it's just the mass number. Any questions from this first page? All right. Next page. So sig figs. Oh, geez. There's the calculator. Sorry, I forgot to do my math. To punch those in. A quick comment, this practice is not necessarily completely inclusive. It was the best I could do trying to put things together. Go back over your study sets, everything we've done. And so I just pulled out things that I was remembering. Right, our answer is 0.044. 226607. So if you give me that as an answer, you're not going to get full credit for that. So does anybody want to tell me what the answer is and why? That is what your calculator will give you if you put it incorrectly. There's two big mistakes with this answer.
There isn't the unit of measurement, and then it's not in the correct number of sig figs.
How many sig figs should it have, Mindy?
It should have 2.
Yeah, so when you're multiplying and dividing, we're looking at the factor with the least number of sig figs. So reminder, zeros to the left of the non-zero are not significant. This has only 2 sig figs. So my answer should only, you don't want to lose the 0, but it is not significant. Units is a bigger deal. Without units, it doesn't mean anything, but 0.044 grams per cubic centimeter. A quick comment, because Mindy answered that for me. If you're going into nursing or pharmacy, please put the 0 before the decimal. They will actually mark you wrong in nursing school if you don't put that 0 there. I have been told by students, and yeah, I personally don't care. If you want to put in scientific notation 4.4 times 10 to negative 2, that's fine. That's not a big deal on this one. All right, on the next one, does that say 1.2? Yes. So this one's interesting because, so your calculator will give you 1851.3. So again, we want units. When we're adding, we just have to have all the same units, so grams. But your calculator is disregarding sig figs. So you need a 0. So when you add and subtract, the rule for sig figs is place value. So this went to the 1,000th, to the 1,000th. So the place value when you add and subtract determines your sig figs. We don't use that rule hardly at all, but it is the rule. We do that multiplying dividing rule more often. And again, it is what I keep saying, it's a respect for sig figs. You can't, your calculators can give you all these digits. All right, factor label, practicing it. Yeah, I'm gonna go through the setup. The answers, I'm pretty sure my answers are right. I want to remind you, I try to highlight, but having different colors or highlighting, so that's our information. And it wants us to figure out how many minutes. So writing down your goal. We're trying to get to 1 unit. You want to start with 1 unit. It's, if you're trying to get to 2 units, then yeah, you would start with 2 units. That's the pitfall, is students want to start with the first piece of information. But take a deep breath, highlight the pieces, and if you started here, the problem's going to be it's per second. And so this is going to end up flipping over. We want to get our miles to centimeters. So you can either go miles to kilometers. I'm going to go that way. And kilometer to meters. Just in the interest of time, I'm going to walk through these pretty fast, but you can go back and do it yourself. And then if you want, look at the video, and then centimeters, meters to centimeter. Again, how you do your metric, I just need to see it in the factor label flow. And then this step flips over. So the 536 stays with the centimeter and the second is on top, and then 60 seconds to 1 minute. And we're limited to 3 sig figs because of our rate. And I'm assuming my answer is okay. You will see probably a metric. You'll see metric. We keep running into metric. So a reminder when you see the slash, that's why I like these boxes like this, but you can do parentheses because you can only have 1 unit on each level. So nanograms over 1 centiliter, and I'm trying to get to milligrams over deciliters. So we change 1 at a time. I recommend that you go to the base units to change nanograms to grams, grams to milligrams. Cross out if you're having trouble. And then if you want, you can change centiliters straight to deciliters. That's great if you know how to do that, right? There's 10 centiliters in a deciliter, or go through the base unit. And so I'm just trying to be consistent, right? You guys know how to do that. If you're using my chart, the 1 goes always with the prefix. So my 1 is 1 nanogram, 1 milligram, 1 centiliter, 1 deciliter. I don't really care. I need to see the work in factor label, and you just want to be consistent. So nano is defined as 10 to the -9th. Milli is 10 to the -3. Centi is 10 to the -2. Deci is 10 to the -1. That's not how I would have actually done it, because I'm able to convert between the units as you get more and more comfortable. But on the celebration, just go with the way that you're going to be comfortable with, that you can move on. So, all right. And then the next one, right, all about mercury. So there's our density. Oh, I wanted to do this one because the last question on your worksheet, it's what a couple people have been asking me, and those of you weren't able to come in and ask. So a cylinder, the volume is pi r squared times the height or the length. So that's our volume. That's going to be in your first box. And so we show pi, the radius is half the diameter, so 1.234 divided by 2 decimeters squared. And then my height is 3.456 inches. So there were several people asking me earlier during my office hours, and I'm sure all of you at some point have pondered this. It's the last question on the worksheet. So this is the idea of what would go in that first box. That I want to see the actual numbers that are given in the problem. And we want to go to centimeters because a milliliter is the same as a centimeter cubed. And so you can change decimeters to meters, meters like we did up here. Or, in case you don't know, there's 10 centimeters in a decimeter. If you want, with your handy dandy little metric chart, something that can be helpful is there's 10 centimeters in a decimeter, or 100 millimeters in a decimeter. So that allows you some people, that's a handy one because we keep running into those. I need to square this step. Not cube it, just square it because I have decimeters squared here. And then my inch, change my inch to centimeters. I don't square or cube that step. That gives me cubic centimeters. And then you can go on from there, the 13.7 gram per milliliter. So you can show the step that a cubic centimeter is a milliliter, but a milliliter will cancel out our centimeters cubed. And so this was the question several of you were asking, that you could get to my answer, but showing it in a factor label. And then I just wanted to kilograms. So So 10 to the third gram is a kilogram. And I'm fairly certain my answers are right, but if you're doing it and you can't get to my answer, you can ask. Is there questions on those? All right, and number 5. So you guys can have an advantage because I've never done a review like this. Usually, yeah. So being able to videotape. I wanted to go through, this picture was in your lab, the first lab. I do recommend going back and looking at the post-lab questions because we're going to talk about accuracy and precision, but some of you had a funny answer on this, and I wrote a note, but sometimes that is this reading, 36.4 milliliters. So this is the meniscus, that curvature, and you always read the bottom of the meniscus. It talked about that in the lab. There was a lot of information. The naming lab, those first few pages of all my writing, there's so many words. Go back and read it. Now that you're starting to know the nomenclature a little bit better, they'll start making sense and little pieces will fill in. And same with the density lab. You don't have to read my story. I don't care about that. But go back and read like my explanation about accuracy and precision, because that might help some with that. All right, so that was the reading. So you probably will see where you're going to have to look at a graduated cylinder because trying to simulate something real. So we're trying to find the density of a metal, and so density is going to be the mass over volume. So the mass of the metal over the volume of the metal. This is the second method, the very last part of part B, which was the meniscus method. So we would have to take the mass of the cylinder plus the metal plus the water minus the mass of the cylinder plus the water. This piece of information here is not needed. It was actually extra information. So we would subtract that, and then we would divide by the volume of the water plus the metal minus the volume of the water. So you can plug in the numbers. Just in the interest of time, I'm not going to go through the whole step. But I wanted to write out in the words because when I said label, this is what I mean. You don't have to write out full words. You can use abbreviations. So M is mass and V is volume. H2O is water. Cylinder. Right. And then, oh, I didn't give an answer. So I guess we have to do this. So you would then show plugging in your numbers. Right. Blah, 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 plug in your numbers, and we punch it in, and I'm just gonna, if somebody has a question, you can ask what I'm trying to punch in. I did want to point something out. All right, so you would show me your work plugging in, and you get 6.89. And you can say either grams per mil or gram per cubic centimeter. Again, they mean the same thing. I do have a question. Why is it 3 sig figs?
Because the dry graduated cylinder is a measurement, and it's only
the volume of the graduated cylinder gives us 3 sig figs. So it limits by the least number of sig figs. I guess my question actually, when you subtract the 47.4, like some people break this into steps. Step 1, step 2, step 3, which is fine. I think on the test might be 5 pages because I spread these the questions out more. So I gave you more space. If you break it into steps, please make sure you label step 1, step 2, step 3. But this is something, I know there were some of you back when we did the first lab, like all of 2 weeks ago. This is what I meant by showing it in one step. When you do the subtraction here, this is not 11, it's 11.0 milliliters because of the place value thing with subtraction. And so that's why we keep the 3 sig figs for that. And so that was one of the big pieces in that lab was all those subtractions. Your calculator will lose the 0, but we're respecting the sig fig rule of adding and subtracting to keep it there. Percent error. We did this in the lab. It shows up in the lab this week again. It was in a study set. So it is the actual or the accepted value minus the experimental. I don't know, that was about experiment. Sorry. In here, just because of time, we're doing absolute value and then times 100. So the actual means it has to be given to you. So the 6.7. And this would be my 6.89. And I'm pretty close. 6.7, 6.89 is not that far off. I would have been really, oh, I did pretty good with that lab. This week, you do have to analyze me. You can say you still want to be my partner. I don't know, because you love my hats and stuff. But you do have to be critical in the analysis because I definitely do not have perfect data. And that's just part of it. I did want to mention also in physics, this lower number is the average of the two. I don't know why they do it. I do know why they do it different, but it comes out around 2.8%. Now there was a comment 1 or 2 people made because it said, how did I do? And they're like, I don't know if that's good data. You know, this is not bad. So you could say, well, it's fairly close. It's not as good as being like right on, but 6.8 versus in 6.7, we're in the ballpark. Now, if I'd gotten like 4.89, that's like really not close to 6.7 or 22.5. That's like nowhere near. I'm like way off. Or what if it had been osmium, which is 22.5 gram per milliliter? I like was way off. So, precision, accuracy is the bullseye, the actual. So I wouldn't say I'm very precise. I would say, you know, we're in the ballpark. It's not bad. There's things I could have done better, like be live and real and not in this world, this virtual world, right? Precision, there's 2 definitions for precision. One is the method in lab where I kept doing masses instead of eyeballing allows more sig figs. So more place values is one definition of precision. Another definition of precision, does anybody remember the other definition?
Isn't it like how close multiple measurements are?
Yeah, it's repeating the same data, repeating similar data. So it's being able to repeat and get the same thing. In a couple weeks, you're going to get to watch me do a titration lab, and I would desperately love to have like somebody else do it, but I'm going to go in this weekend and titrate and see how I do. And in titration, we always do it multiple times and average our numbers. So we can't really say how precise this is. The eyeball method is always not as precise as the other one, just because you're eyeballing it. So it has more human error. I'm going to move on because we got 2 more pages. But again, I stay after today or come in early. We're going to practice nomenclature. So, yeah. I can pause for 5 minutes and give you guys a chance to play with it for 5 minutes, or I can keep going. What do you want?
Just keep going.
I'll keep going. I recommend for all of you, well, you can try and write this down really fast. Please remember, I am videotaping. So you can actually, my other class who's been with me for 2 terms, a lot of them have said they actually sit back and knit during class and just listen. And then they go back and watch the videos later. And so realize you can fill in. This first question is really important. Which ones are molecules? So just one through, we can go 1 through 9 because I added that question. Anybody see which ones? There's 2. This is back to, go ahead. What are you going to say, Major?
The number 4.
Yeah, so this is back to the question Spencer had asked. So molecule means we have non-metals. And so this is going to be number 4. This actually can be a really important question to ask yourself when you do the naming, because this one is named different. And so it's nice to do that one first. This is going to be the one where you do not have any ions, pentafluoride. Or if you did, they would both be negative and you'd go, oh, I can't have 2 negative ions. This must be where I say how many there are. And the other one would be the acid. So even though a lot of people like to think about it as if it's ionic because it's easier to teach that way, it is truly a molecule. Water then pulls it apart. It's a polar molecular compound. So acid is the hydrogen, and then the IO4 is periodic. Acids end with ic. Having a nice list. Again, that page 2, which is not overwhelming. And again, iodine is going to behave like chlorate. It has an extra oxygen, so per, and we change it to ic. All right, on these other ones, so iron gets a Roman numeral. And this is just chloride. So I'm looking at the ending. Hopefully, as I'm going through it, again, you can just listen and fill in later or take a picture once I get it done. Hopefully, it's starting to make sense. And then the Cl is a -1, so the iron is a 2. So iron 2 chloride. Sodium is just sodium. First 2 columns, periodic table, no Roman numeral. And then you can add a parentheses, check your list. PO4 is phosphate, so it's just sodium phosphate. Cr is chromium. It gets a Roman numeral. And we'll figure it out in a moment. NO2 is polyatomic. Nitrate is NO3, so this is nitrite. So again, ite just means -1 oxygen from our list here. So the charge is whatever it was for the nitrate. So -1 times 3, chromium 3. Oh, sorry, number 5 was also. So 4, 5, and 8. I didn't realize I had another acid there. So nitrate becomes nitric acid. All right, Na is sodium. And then this is back to like the question Mindy had been asking me and somebody else. There's 2 parts. So put a parenthesis. You're not going to say sodium chlorine oxide or monoxide or something. The ClO goes together. This is going with the chlorate. Ite, if you lose 1 oxygen, if you lose 2 oxygens, that's what's happening here. It's hypochlorite. You guys don't have to remember that. It's on that page 2, print out page 2, so you have it there. If you do the lab, the worksheet, if you go back and do this, you've got it. And then you're not trying to Google weird answers and stuff. Yeah. All right. Google is so funny. All right, vanadium. And this is just sulfur, so sulfide. And this is one where they do truly switch. So -2 and a +3, so vanadium 3. And then just a reminder, so 2 parts. K is potassium, so add the parentheses. And so carbonate with a hydrogen, you can either say hydrogen carbonate, you know, it sounds like it is 2 words, or it is more commonly, everybody calls it bicarbonate. So let's just all call it bicarbonate because it's like water. Nobody calls it dihydrogen monoxide except as a joke. All right. And I'm going to just keep going unless somebody has a question. On celebration, it is going to be like on your worksheet, you're going to have to show me the ions. So I'm going to go through because I do that because it makes a difference. So titanium is our cation, oxygens are anion, like how I'm dressed. You know, if you dress up for the celebration, you get a bonus point also. And if you're dressed up, it will make you giggle and not take yourself so seriously, because how can we take ourselves so seriously? All right, so make sure that I is dotted and that O is a capital O. Gold is AU with a +3. Chlorite means chlorate. Take away an oxygen, so ClO2 with a -1. So AU, parentheses, ClO2, and then 3. So ClO2 is chlorite, and the 3. Also, please be careful, and you guys actually are really good at this, keeping these as subscripts. All right, and again, this is one small section of the celebration, like 10 points of it. You'll also have questions like these that were like on the worksheet. So, right, hydroxide is OH. It is acids are hydrogen. So the other half of water is hydroxide. And so calcium's a +2 and OH is a -1. The most missed thing on this one would be people do that. And that is wrong because that's showing 2 H's. We want to make sure we put a parentheses and show 2 OH's. All right, acid means we have hydrogen. And again, you can show the ions for acids, or you can leave that part blank. Hydro means no oxygen, so it's just H and I, so it's high. How's it going? Hydroiodic? Anybody the other name for this one? This would be if it's aqueous. All right, manganese, +2, and bromide is Br with a -1. So IDE means it's not a polyatomic. Not everything's a polyatomic. And yeah. All right, MnBr2. Aluminum +3. Sulfite. So again, we go to sulfate and we take away an oxygen, but you keep the charge that sulfate was. So that little chart I made was just an example of chlorate. Right, so 2 aluminums, 3 sulfates. This is so good for your brain. So like, it is a new language. We're learning a whole language. See how much you're like getting everything in one class. Speech. All right, acid, hydrogen. Phosphorus is the same as phosphite. So instead of PO4, we have PO3, and it's still a -3. So hydrogen's a +1. You need 3 hydrogens, so H3PO3. So hopefully it's hopefully it's better than it was last Thursday. You know, it is a whole language. Vincent, it's going to be like 10 more minutes. So if you want to sign off and come back, you can do that. But yeah. All right. And then this one, I added these two on here. I already did them, but again, this is back to the question you were asking, Mindy. These were on the lab, or I think on the lab they were with potassium. So the dihydrogen phosphate is your anion, H2PO4, has a -1. Hydrogen phosphate is just HPO4. So that piece stays together and it's -2, and then they're each with sodium. So the first one be NaH2PO4. And then the second one, we need 2 sodiums and then HPO4. But I threw those two on there just because I realized I threw them also on the study set, but hopefully you're starting to make a little more sense, but they're just one piece of everything. And just because several people had questions about them on Saturday or Sunday. All right. Number 1 is, this was right from your study set. So X has 2 valence, so X is +2. Z has 5, so it would be -3. Needs 3 more to get to an octet. So we just swap them, X3, Z2. All right. Calcium as an ion. So we find calcium. Calcium is, this is like what we just did on the chart. Calcium is 20 protons, and then we would lose 2. So 20 protons and 18 electrons. And so again, the naming, yes, but it's also, there'll be just as many points of these questions that say, you know, do you understand how these are related? Yeah. All right, isoelectronic, iso, it means same. So they come out the same as neon. So sodium, it had 11, it loses 1, so sodium will. Potassium, no. Potassium's going to come out like argon. Titanium 2 will not work. Sulfur also comes out like argon. So sodium was the only answer on that. So again, potassium, because it was at 19, so +1, it would become 18. Sulfur +2 would become 18. So they come out like argon. We had a question like this on one of your first study sets, but we didn't have charges yet. So you figure out chromium has 24 protons. We subtract 28 neutrons. And then the +3 would mean it has 21 electrons. Yeah. And then for the manganese, right, manganese is number 25. So it has 25 protons, 25, 50. So this is 25 neutrons. And then +2 would mean 23 electrons. So none of the subatomic particles came out the same. My mass numbers are not the same, so that rules out the nucleons. 52. You know what? They come out the same total subatomic. If you add up the electrons, protons, and neutrons, it comes out the same. Yeah, you know what? These questions, they're looking really familiar to me. They came right off of the midterm, the first midterm from last year. So you guys are being given a huge gift here. My biggest concern is if you don't study and you're not prepared and you're going to rely on Google to give you answers, you're not going to finish in 2 hours. And so do it. Do your own work. Feel comfortable with it. You're going to have to show your work. This is kind of back to what we were talking about. There's actually hundreds of polyatomics, probably thousands. And so there is one called molybdate. So barium's a +2. This is kind of one of those logic questions. It's good for your brain cells. So MOO4, this is back to Mindy again. They're binary, there's 2 parts. So the MOO4 must stay together. And this must be a -2. So that must be what molybdenate is. You can even say that. Thankfully, it's not a speaking test. So if I combine sodium with it, I would need 2 sodiums for every one of those. So if that makes sense, you can go back and think about that. Questions? And again, I'll be on after. If you have to go, we did pass 8 o'clock. The last page I'll get through in 10 minutes. And then this will be uploaded. My computer turns off at like 9 o'clock. So sometimes the uploading doesn't happen until the next morning, and I apologize. This one's not wired into the Ethernet, and it just Zoom takes a long. Zoom will not back up until I sign off of Zoom. The backside, I think the math on these you guys should be okay with. The answers are there, so I'm not going to walk through. The only one I want to remind you of, I do want to do the ones at the top, is, oh, sorry. So again, this is because Bill Gates and I struggle. Bill Gates also doesn't like a lot of chemistry, and this is my sad sense of humor. So he's always changing molarity to morality. So caffeine's morality is a whole nother issue. Depending on what people put in. That's what Major does for a living, so he can have a discussion. But I wanted you to solve for molarity, which is moles per liter. So you would start with 120 milligrams over 12 fluid ounces, and you would go to moles per liter. Yeah, so you guys should be great at moles. You can start with the moles questions. Empirical formula, you guys all know how to do that. The biggest thing is showing your units, showing it nice systematically. I do want to go through the 3 at the top, and I'm fairly certain my answers are correct. If you do try these and you can't get to my answer, you can send me an email, or again on Thursday, I will be on before 6 o'clock. Again, the celebration will magically appear at 6 o'clock. It's just how electrons work. And I'll be on Zoom, and you have 2 hours. And when you submit, I do ask that you just check in with me so I can say, yeah, I can see it. You can check yourself. You're also going to sign a thing at the top. I unfortunately have to have this conversation with this class because it was my 222 and my 223 last year horrified me because they had no morals. The level of cheating that went on. And so right now you guys get the benefit of the doubt. I'm not going to babysit you while you're taking your test. You ruin that. 1, you get a 0 and the game changes for the class. So don't do that. Those of you from 151, somebody at the final decided to do that. And so I had a lovely next day with writing a whole nother test for them. And was not fun. So don't cheat. Do your own work. That's why if you look, your test is only 80 points. It's your 3 exams don't even add up to half of your grade in the class. So your class presentations, you guys did great. Your labs, all these other points add up. So it's just not worth it. Don't do it. All right. Yeah, because all these other people in the class are really lovely and they don't need to see me not smiling. All right, which one has the most oxygen atoms? So this one has 5. You're looking at the number of moles and the subscript. So we get 5 here. Here I got 4 times 2, so I have 8, but then I have double it again. So this one's probably going to be our winner. Here I have 3 and then times the 3, so 9. So you're figuring out the number from the subscripts as well as the moles in front. And then here would be 2 times the 4, which is 8. So it's looking like B is our answer. And then, well, number 2, 5 grams would have the most atoms. You don't have to solve. If you just do your first one, so aluminum, you would be dividing by grams to get to moles. Whichever one has the most moles is going to have the most atoms. So you're dividing by the molar mass. Aluminum's going to be our winner because it's the smallest. So you're going to have more packed into the mass, more atoms packed into the mass. You can ponder that. And then the last one, which is not an empirical formula. Let's see. Because you could reduce it. So C2H4O. So empirical formula is the lowest ratio. It's what all of the ionic compounds, we do the lowest whole number ratio. Molecular formulas are not necessarily empirical, so we could reduce that more, and so that's why that one was the answer. And again, these were questions right from previous. So the test might have some questions like this that are multiple choice format, but it will be laid out similar to this, where it will be, right, periodic table stuff. There were some ions that we can now apply, our math stuff, our naming stuff, and then our moles. So I do try to segregate it. I do want to mention, because we're not using Scantrons, it's not that sometimes there are multiple answers, like which is not. There might have been 2 of these, so don't go into it because you all have schooling background where there's only one answer. There can only be one answer. Like on the first page with the true and false, we had a couple that were true. So sometimes there is only one, sometimes there's more than one, because you're just going to circle. And again, if you have a printer, that's wonderful. If you don't, you don't have to write the questions out. You just have to write the answers out in the same order as they are, showing your work, right, where it's factor label. Any questions and any late assignments to get in? You guys have this. This is good practice. I actually have office hours tomorrow night too. So if you desperately need to talk to me, send me an email and I can send you a link. My other class is taking a test also. So I just sit around for 2 hours writing your test probably. And to answer my bonus email, and you can stay on now. I'm going to stop recording.